Swayam Prabha. Digital India. Educated India.
Hi students, hope you all are doing well. Welcome to another exciting session of the course Soft Tissue Characterizations and Applications. So today we are going to continue on the finite element modeling of soft tissues. We had completed a few lectures on learning different concepts, how to use the finite element software, what are the different steps of understanding the modeling techniques. Last class we had spent quite a bit of time to understand meshing, right? How to do a mesh convergence study in order to understand that and optimize the mesh in such a way so that the mesh doesn't affect the results. The selection of the mesh doesn't affect the results. So how do we select the right mesh? So that was studied in the last class. In today's session we are going to cover another very interesting and important topic, which is on the contacts. So how do we establish contacts between bodies when they are separated by a certain distance or just touching each other? This is a very common phenomena with organs and tissues which are located right adjacent to each other, right? So how do we model those interactions, two body or three body interactions? So this is what we are going to focus on in today's session, and slowly move towards a much more complex problem where we'll try to find all the different concepts where we have learned so far, apply all of them to a realistic complex problems of the human foot, right? So let's get started. So we are going to come back to where we were in ANSYS. This was the screen we were looking at. So I'm going to start with a blank screen and just kind of repeat all the steps really quick as a refresher, and then move towards making two bodies and looking at the different methods of creating a contact, right? So let us go for, so clear and start new is done. That's for clearing your screen. Then the next thing is we go for structural here, preferences, that is done, right? Next is preprocessor. We have to select the element type. So under this add edit delete, you select solid 186, right? We close this out. Then the next thing what we do is we basically go for material properties. Oops, I clicked the wrong one. So just make sure your mouse is not super sensitive, like while you are working with these kind of softwares, otherwise you may click somewhere here and there, right? So I'm going to hit on the material models and go to linear, elastic, isotropic, and go for a material property, let's say 10,000, and just make it 0.4, right? 10,000 is a little high property, it's almost going towards the cartilage or bone, so let's keep it to 1000 maybe, right? So I'm going to delete 10 and just update this to 0.4. Okay, so this is done. Material properties is done. The next thing which we do is we focus on the modeling, right? So so far we have majorly worked with single body models, right, where we had either a rectangular body, or you would call it a cuboidal body, or a spherical body, or a certain structure shaped specific bodies, right? Like, and we have applied different kinds of loadings and boundary conditions to it, and we have also understood the overlap operation, where there is a penetration between two bodies, and how the overlap operation makes sure that they are totally integrated in a way that there is a if you had the initial body as A and B, then the new bodies created are A minus B, B minus A, and A intersection B. These are the three new volumes which were created through the use of the overlap operation, right? So the next thing which we want to look at is not all bodies overlap, right? What if they are just touching each other? Then what is the criteria there, right? So as we know that in ANSYS, the computer does not understand any interaction unless there is an operation which is creating that interaction. So when we have just two bodies in air, even though they may be touching or may have an overlap, the computer will not understand that unless you apply the overlap operation or create a contact condition for the touching bodies, right? So that should be very, very clear. So having said that, what we are going to do is step one, we are going to create a body and then have a common surface which it is sharing with another body which will be created from that body, right? Or using one of the common surfaces in that body. So let's try to do that. So I'm going to use the bottoms up approach while I do that, right? Or what I could do is I could use the bottoms up approach and a mix of a standard method where I straight go to the model. So let's create a model first. I want to create a volume, and as we know, we can only create very regular volumes using this option, and bottoms up approach allows us to use different kinds of techniques through points and connections and creating areas and volumes to create much more complex geometries, right? So I'm going to create a block by dimensions, and this is going to vary from 0 to 5 along the x-axis, 0 to 3 along the y-axis, and a 0 to 2 along the z-axis, right? So let's go ahead and create this. There it is. We must keep our dynamic model mode on at all points, and I'm going to fit this to view. And if I use my mouse pointers, I'm able to rotate it. And I know where my Cartesian convention system starts from. So that's the origin with the x, y, and z, right? So this is what I have as the body. The next thing which I want to do is I want to create a few points here and create another body using bottoms up approach when I make sure that the face or the surface on the very right is being shared with that body. Let's see what that means, right? So first thing which I'm going to do is create some key points on active coordinate system, right? So what are these key points going to be? So one of these key points, of course, I went till 5 along the x-axis and I went till 2 along the z-axis, right? So I'm going to go somewhere like maybe 7, and along the y I'm going to go, I went all the way up to 3, so I'm going to go to -2 and then +2, right? Like 3 plus 2. So then I'm along the z, I have to focus, let's start with 0. Okay, so this is my point number 1 which I want to create. Here is the point, right? The next thing which I want to create is along the z of 3, sorry, z of 2. So this is the next point I want to apply. Then what I want to do is so I want to add 2 to 3, which is 5. I want to create something like this, 752 apply. Oops, now there is something wrong here. It should have been, I believe, yeah, something is created, 12 point, right? That's okay. And the last one which I want to create is this one, 750, right? Okay, so these are some of the points. One thing which might have been a mistake, I understand there are 2 points I've created at the same place by mistake, right? I could see that through some slight visual overlap. So I'm going to delete the it's a little sensitive mouse, so it's going to click a few places here and there, but that's okay. So I'm going to delete the key point at this location, and this lets me select between 10 and 11. So I can choose to have any of these, right? Like I'm going to get rid of 11. Oh, so there's something wrong which happened. So yeah, I see some clear points here. So that's great. So what I'm going to do is I'm going to plot all the lines, maybe plot multi-plots so that I can see everything. I want to switch the key point numbering on, right? just so I can see all the key points very clearly. The next thing I want to do is I want to create this new body which is going to share the common surface encompassed by the point 7346, which is very clear here, right? Like it is the right side surface of this block. So next thing I'm going to do is create some lines. So I am going to connect, oops, that's wrong, cancel. Hopefully no new lines were created, lines only. So maybe 3, oops, it's a little too sensitive. So oh, it's in the delete lines. I'm in the wrong segment, that's why. Yeah, sometimes you cannot figure out because the options look very similar. So I'm going to select straight line and select, oops, no, there's too many points are being selected, so this just reset. So this is point 1 and I'm going to go for which one, point 14 I believe, then point 12, then next is point 12, oops, selecting too many points, reset, select point 12. Oh, point 12 also has 2 points, so by mistake it was created, so I'm going to stick with point 12, okay, and make it to 3. There's an extra line which is created here, we need to remove that. So let's get rid of that. No, may not have been created. So plot lines just to be sure. Yeah, it's okay. So plot, how many lines should be here? So we should ideally be just a sanity check, 1 2 3 4 5 6 7 8 9 10 11 12 and 3 more, right? So let's just check how many lines do we have. 15, correct, right? So this is all good. I'm going to get rid of the point 13 under delete. Do I have to get rid of the point? Not really, like oops, it's clicking too many things. It's okay, I don't have to necessarily get rid of my points, they can just stay, right? Like no big deal. Because I am not concerned with them. The reason I want to delete them is I don't want any confusion that in one place I'm selecting point 12 for creating a line and in the other place I'm selecting point 13. Then it will miss a connection, I'll not be able to create areas, right? Because the lines are not continuous, right? They're not connected to the same point. You need a continuous set of lines to create areas. So that's why it's better to get rid of redundant points. Oops. So it's yeah, it's just too sensitive. Just going to remove this and select, oh, this is something else has been selected. So I was in the delete operation and I should stay there, and I was trying to delete a key point. Yeah, there it is. So I want to get rid of this key point 13, right? I should be able to, that's not a problem. So plot multiplots is still good, right? So the next thing is I want to make the other lines here, get out of delete, create line, straight line. So I'm going to select 12, 10, 10, 9, great. Yeah, not this, maybe reset this. Right, cancel. Okay, good. So I have another volume in making. The next thing is I want to create areas, and one of these areas already exists, which is encompassed by this 7364. So I'm going to use it from this model, right? And so let's create the other areas. How do we do that? Just a refresher on the bottoms up approach. So we go for arbitrary by lines. These are the lines which you select, right? And that takes you to that. something was selected, but it's okay. So area 2 was done. Then the next thing is just go, oh, area fillet is something we don't want. Arbitrary highlights. Okay, unpick this guy. Yeah, this is another area. Apply. Then I want to create another area here. This is selected by mistake. Apply, and the last area is remaining. Right, so this is good. Okay, so we have created another set of areas, and I want to then use these areas to create a volume. So 1, 2, 3, 4, 5. Oops. Oh no, that's too many. Yeah. So these have been selected, and then finally, oops, yeah, this mouse is actually causing a little bit of an issue, so we'll get into that, right? So let's select all this again under the modeling areas 1, 2, 3, 4, 5, 6, not these, of course. Hopefully everything is 6 areas are selected. Okay. Yeah, that has created a volume. Perfect. So if I list my volumes, I would see 2 volumes, right, which were created, and these 2 volumes are good. Okay, now the point here is, are these 2 volumes interacting? That's the question which we have to answer, right? We have created one volume directly and one volume by sharing the common surface. Now we want to go ahead and mesh them and figure out whether they have an interaction. We can have 2 different material properties if you choose that to be, right? So under material models, let's make another material property. So I want to make this to maybe 500, right, and 0.3. Okay, so the next thing is we want to now go for meshing. So I'm just going to go to standard meshing, just set the material properties, right? So material 1 is to be applied to the left side model. Oops. Only. Okay, meshing is done. The next is then we want to apply the mesh tool option to the next one, material model 2. Yeah, yeah. So one thing which we can observe very clearly here is the meshes are percolating very clearly wherever the first mesh ends, like the elements and the nodes there are kind of transitioning to the next mesh, which showcases that there is an interaction. And if I just look at plot controls, numbering, and set this to material numbers and colors only, then I can clearly see these 2 materials which are created due to the 2 different models, but they seem to be connected. The next step of sanity check is when I apply a constraint to one body and load to another, then if they perform fine, then they are basically validating the criteria that at least there is one constraint and at least there is one interaction, which is the minimum criteria for a two body problem, right? So let's go ahead and do that. Let's apply some loads. So I'm going to define loads, apply structural displacement on areas. Oops. Yeah. Okay. So all degrees of freedom, I want to hold this. Then I want to apply a pressure on another area of a different volume. Let's say this. Just this one, right? Oh, select something else by mistake, I think. Pressure on areas. Yeah. Hit OK. And then, oh no, this is clicking something else, so that's the problem. Yeah. Just the mouse is a little tricky. It's okay. We'll make sure we can do this. Okay. Yeah, you may face the same issue, like so. Just work through it. Okay, here we are. So we are good. Okay, so we are looking at basically the model here where the load and boundary condition have both been applied, and then the next thing what we want to do is run an analysis. So go for solutions, analysis type, new analysis, and solve. Right, solution is done, which indicates that there is a clear connection between the two bodies. And let us just look at the general post processing just to be sure. So we are looking at, okay, so there is a clear deformation. You can see the pressure which has caused the other side to bend in a certain way because of the pressure, right? And we can see the same through an animation. Just as a refresher, and this is how the animation will look like, right? So clear interaction, and you can look at that both bodies are interacting, right? Then the next thing is you look at the result viewer, and you can look at the DOF solution, displacement vector sum. Here clearly you are looking at all the displacements which are transitioning from one body to another. You can look at stress von Mises. You will see a very similar trend where the stresses are distributed fairly across both the bodies, right? Okay, so that was the step one for showing a connection, how to create a connection between two bodies when they are just touching each other through use of a common surface method. And all of this is implemented through modeling technique, where you use bottoms up approach to create that modeling interface. There is another way you could have done this probably. So what I can do is like just select the surface on the right and extrude it. That creates another body, right? Of course you cannot get the complex shape, but it could have an extruded body, like where you have uh, two volumes, one is an extrusion of another, and they are also perfectly connected because it's sharing a common surface, right? So whenever there is a common surface sharing, those bodies are connected. Now what happens when bodies are touching each other, but some places there may be some gaps, and of course there are bodies which have clear gaps, small gaps versus large gaps. What do you do in those kind of scenarios? So that is where we are going to take our target next, like which is learning about a technique which is known as contact pairing. Very important technique in ANSYS, like which is used for all the 2 or 3 body problems, right? So let's go about that. Let's see how to do that. In order to do that, I'm going to clear and start new and start a fresh screen. So again, preferences, structural, preprocessor, element type, add, edit, delete, solid 186, material properties. I'm going to go ahead and select 2 different material properties, because we are going to talk about 2 body and 3 body problems only from here. So let's look at 100.4, 1000.3, right? So we have 2 bodies in a way like which is basically giving all the mechanical properties, right? Okay, so let's now create the 2 bodies. So I'm going to model it very simply to start with. So let's create that. So I'm going to create 2 blocks which are just touching each other, right? But of course not sharing the same surface, which is clear. So the first block will start from 0 to let's say 3, 0 to 2, and 0 to 1. This is my block number 1. Okay, of course it looks big, but like it may not be that big. Yeah. So my block number 2, what I want is to start from the end of this, and so this can start from along the x from 3 onward to up to like 5 or maybe 7, right? And the y coordinates can vary from 0 to maybe 3, right? That is quite possible. Z can stay the same, or Z can also change. Z can be from 0 to 2. Okay. So we have 2 blocks which are just touching each other, but of course there is no common area. This is just a matter of visual touch, and there is no connection at all. Okay, so next thing is we want to create an interaction. So this contact pair based interaction, before we can create that, we have to mesh the 2 bodies first. Please take this as a note, like in order to apply a contact pair, we need to mesh both the bodies first. So meshing means there needs to be a declared mechanical property as well as declared element type. That has to be there. That's a prerequisite, right? So next is I am going to go to mesh tool and just go ahead and mesh it. So material 1 is selected by default. So I'm going to select this guy, and then I'm going to select the other one. Okay, so I have 2 different material assigned to 2 different bodies, like which are just touching each other. I'm going to look at it from a colors perspective just to be sure. Yeah, right. And one thing is very clear, that the meshes are not interacting or transitioning at all, because wherever this point ends, that is not where this mesh starts, right? Like, so there is no interaction, very clear. So next is to apply the contact pair. How do we do that? We go to modeling, we go to create. Under create, there is an option known as contact pair. Here it is, contact pair. Okay, so we select here. Under contact pairing, what we do is we start this contact wizard. There is just one option here which is on, which is good. Under contact wizard, you will have options of having a target surface and having a contact surface. So what is this contact and target? So typically whenever a bullet is, let's say, hitting a body, then the target is the body, the contact point is the bullet, right? Similarly, when we are pushing something onto something, our the thing which is pushing is the contact, and the one which is being pushed is the target, right? So that's typically the definition, very subjective, but there could be definitions in which both of them replace each other. But just consider one of the surfaces or one of the bodies here in context to be the contact, and one of the bodies here to be the target. When we are talking about contact and target, we are specifically focused on the surface which is going to be in touch with the other body's surface. Okay, so our target surface, if we choose our things in a certain way, let's say I want to push this bluish green body by the purple body, by constraining the bluish green body, and then I want to push it on, push the purple body onto the bluish green body. That typically means that my target is the bluish green body. Okay, so let's pick this target. So under the target, I'm going to select this surface which is facing the other surface where I want to establish the contact. It's not like this surface or that surface. The surfaces should be facing each other. They may not be directly facing always. There could be a little bit of incline or undulations and things like that, but at least they should be facing. There should not be a surface which is facing this way and the other surface is facing that way. Those are not the proper surfaces to have a load transition, right? There needs to be some facing, right? So okay, this comes back and it shows nothing, but it has already taken the selection. Next is, you go for next, you go for pick contact, in which I'm going to select this surface on the other side as the contact surface. Okay, so once I click this, again it shows nothing, right? The type of contact here, or the type of contact element which would be created to create this transition, is known as a surface to surface contact, right? Next is, I'm going to create, select next. Okay, then the next thing is I want to go to optional settings, not touch anything here, and take care of a few things which are very, very important. The first one is the basic, right? Under the basics, what do you have? Your behavior of contact surface. This one is the one I'm going to modify. Rather than keeping this as standard, I'm going to keep this as bonded always. That means they're totally bonded to each other. Means one surface will move when the other surface has some load transfer. This is typically what I consider for majority of the simulation, and it works fine by defining the contact criteria very clearly, right? So always select this bonded always, unless you have some frictional components and other things which come in between tissues and things like that. We're going to refrain from that complex modeling things like so. Just stick with bonded always. Next is go to initial adjustment. Under this, go to initial penetration and go to exclude everything, right? What does this mean? That is meaning basically any kind of initial penetration or overlaps are excluded for the contact creation. They are not considered as a part. Like the contact is clearly between two surfaces, irrespective of how those surfaces are looking visually or interacting with each other, right? So exclude everything. Next is, you want to set this automatic contact adjustment to this close gap / reduce penetration. This just takes care of any small gaps or penetrations are taken care of, right? So far so good for surfaces just touching each other. There would be some additive things you have to tick and check mark when there is a clear difference or clear gap between the two bodies, right? We'll come to that. So exclude everything, okay, right? Good. There is another thing we want to control, that is this friction. Under this friction, we don't want to select anything. The only thing is this material. So whatever material is selected here, that is the material of this contact. So contact is created through some glue or something, right? Like let's say two bodies are welded, two bodies are glued, or there is some interaction through a fascia in a tissue. Like let's say the rectum is interacting with the bladder, or there is a one ventricle of the heart is interacting with another. There is a fascia or some septum kind of material. So those kind of materials are the contact definitions which we are talking about, right? So you can select that with material A or material 1, 2, or if you have the option of 3, those kind of materials you can select for the contact, right? So here we have option of 1 and 2. So let's say I want to select this 1 by default, right? So this is okay. That's it. We go ahead and create. So this creates a contact pair. If I'm going to click here, it's going to vanish. So that's why I'm not clicking just yet. So these two surfaces, basically what you're looking at in blue, those kind of small lines are looking at contact normals. So they are the normals for showing that the load transfer will happen like this, right? So that's it, finish. You just click here and the contact doesn't show here. If you but all these markers or all these buttons now become active because you have already created one contact pair. Now if you go to plot elements, you'll be able to see these elements without the surface normals. Okay, if you want to revisit, if you want to change something, you can go to properties and just update that and hit OK, and that should change it, right? So let's exit out of this. The contact has been created. The next thing is we want to apply a load and apply a constraint just to check whether this contact works, right? Let's go to loads. I want to apply a structural displacement on areas. What did I decide? I want to apply a structural displacement on this face, all degrees of freedom set to 0, right? Then I want to apply a pressure on areas, which is this area. And how much would that pressure be? Let's say 0.5, right? Okay, so all my loads are good. If my contact works fine, then the solution will run, otherwise it will not, because we are looking at two disconnected bodies just held together with this contact pair definition. Sometimes if the solution doesn't run or you see some faults which are reported, it could be because of some contacts which have not been defined properly. Typically happens when you have gaps, and in very complex systems when you have undulated gaps or a spherical body is sitting on another spherical body, where the gap kind of varies from a very small gap to a very large gap from one position to another. So those kind of things get complex when you get to the simulations, and that is what we are going to look at and address in the upcoming sessions with a complex model, right? Okay, so that's good. So let's go for analysis type, new analysis. Don't forget this. We have to do this again and again and solve this, right? Takes probably a few seconds. It is going to run a non-linear solution. That is what you're seeing. So whenever you have introduced a contact pairing, the solution becomes non-linear. That means the stress and strain do not work together. So what does it say? Solution not converged at this time. So there is some issue. There is some issue with this model. And why is this not converged? Most likely due to the contact pairing. Okay. So this is where trouble has come. Now we want to revisit our contact pair. So modeling, create contact pair. Let's exit out of this. So what is the problem with this contact pair? We don't know. So I'm going to put something here in the initial adjustment. I'm going to put a contact offset of 1, right? I'll explain what that is. With that, I want to just rerun my simulation. And just try. Hopefully it works. Yeah, it takes a few minutes sometimes, like, and no, it's still not working. So it could be something else, like, which we need to look at. So these kind of things can sometime become due to the software as well. So let us revisit what our model looks like. So we are looking at some pressures. We are looking at maybe the pressure is a little high. That can also be the case, right? So let's get rid of the pressure and these loads here very quickly. So loads, structural, I want to get rid of these loads. So this is the fault detection time, like, the many a times your solution will not run and you need to be able to figure out why it is not running, and these are the failure analysis things which we do. We want to check the mesh, we want to check the mesh here is okay, we want to check the contact pair first in cases of contact pairs. Second is we want to check on the loads. Is the load way too high for the system? that there is a disassociation going on with the system, right? Like one is penetrating into another or things like that, right? So let me go into this. So I want to delete structural pressure on areas. I want to delete this guy. Okay. And next is I want to apply a pressure again, maybe a little lower, right? So this time I want to apply just 0.1, right? Let's give it a shot. Okay, done. Okay, good to go. So the problem was with the load. I had applied too much of load, due to which the contact condition was getting violated, and that's why the solutions did not converge. So what was the offset I had applied? So offset is basically applied, it is not very favorable in this particular case, but I'll show you the usefulness of offset when there is a gap. Okay, so just let's hold that on for a few moments. So the solution is done. Let's see how the solution looks like. General post processing, plot results, deform shape. Okay, so we can see that there is a clear solution, and let's look at the animation, right? So we can very clearly see that two bodies are moving together, so that means there is a clear load transfer, and of course if the load transfer was not there, the solution would not work at the first place. So next is we want to look at result viewer. Do you have solution, displacement vector? Very clearly there is a displacement transformation or displacement translation from one body to another using contact pairing operation that has been established. If we look at stress, it would be no different, right? Again we are looking at higher stresses at the localized at the point of interaction, and then you have stresses. Why the stresses are like that? And that has a different explanation, but you could see very well that blue doesn't necessarily mean it is zero, because the pointer here, the color bar which you're looking at, the values are starting from 0.012567, and that is corresponding to a very small pressure which we have applied, which is just 0.1, right? That's why the values are low, but it's not zero. Okay, so what may have happened to volume number 2? So if you just select the entities and by elements, by attributes, and I select material number 2, right, then you can see the stress plot here, right? So it has its own stress plot, which starts with a smaller number and it ends at a little lower number again, like compared to the whole volume, set of two volumes. So I select everything and then everything comes back, right? So this is the model number 1, where I wanted to show just with no gap, when two bodies are just touching each other visually and coordinate wise, and then you have no interactions between them, how to use a contact pair to create an interaction. We have ran into one flaw where there was a little bit of overloading, due to which the contact condition was violated, and that's why we got a solution error initially, which was solved by solving the loading. Next is we want to create these bodies with a certain gap, okay, and after that we want to change the bodies from having flat surfaces to little curved surfaces. So these are the two new things which we want to explore, right, going ahead. So let's get into that. The next one is with gaps. So let's start fresh, clear and start new. I like doing this because every time you get a refresher on all these steps one more time. So everybody is advised to practice these simulations, otherwise it's very hard to grasp and really do it. And the software is free of cost, like, so you can download it. I've shown you how, and you can start working on the answers, right? So as I speak, I'm going to select all the different steps here. Material properties. Can I go with one material property? Yes, you can. It totally depends on you. But then you will not be able to distinguish through materials. They will show a single color, right? That's the only detail. Can I have 3 material properties? Yes, you can, right? So I'm going to make 1000.4 as material property 1. I'm going to make another material 2, 100.3, and I'm going to make another material new model material 3, which is 500.2. okay. So these are the 3 models, material models I've created very quickly. The next thing is I want to go for modeling. So here what I'm going to model here is 2 volumes. So first one going from 0 to 5 along the x-axis, 0 to 3 along the y-axis, and 0 to 2 along the z-axis, right? Apply. So this has created this body. Next, what I want to do is I want to go and create a gap here, right? So let me go from 6, so with a 1 point gap. Okay, so how much gap can you actually work out with a contact pairing? So there is no limit to the gaps, but typically the rule of thumb is the gap should not be more than 5 to 10% of the maximum edge length which your body has. So if this is my length, if I'm going beyond 10%, like that is a huge gap, right? Those kind of gap scenarios would have to be handled properly with the right contact pair parameters, but it gets more difficult and difficult when you have a huge gap. Like any system, if you have a huge gap, they're not going to work together, right? So similar with tissues never have this much gap and then they're moving together. There is a certain gap and they're interacting and then they're moving together with a fascia. That is okay, but do not have a huge gap, right? So I'm having a gap of 1 point here, 6 to maybe 9. This what I want to go to, and along the y coordinate I want to go from, let's say, 1 to 4, right? And along the z maybe -1 to 5, right? Whatever it is, doesn't matter. So these are the 2 bodies I'm looking at with a decent amount of gap. It's definitely more than 10%. We're looking at can we work with this scenario? Yes, you can with certain parameters. That is exactly what I'm going to show you, but typically work with smaller gaps, right? Okay, so both these bodies are good to go. The next thing is we go ahead and mesh these bodies. So I'm going to select by default material property 1, mesh this first body, right? Material property 2, mesh the second body, right? Meshing is an important criteria before you can apply the contact pair. Now meshing is done. Next is I go to modeling, create contact pair, right? Now in contact pairing, what am I planning on doing here? So I'm going to force this left side block onto the right side block, and by virtue of that I'm going to call the right side block as the target and left side as the contact, right? So let's create this contact pairing. So first is I want to pick the target surface, which is in this case this, right? Okay, then I want to pick the contact surface, which is this, right? Next I want to go for optional settings, and under basic I want to set to bonded always, right, for the behavior of the contact surfaces. Under the initial adjustment I have to set this always to exclude everything, right? Of course, set this to close gap reduce penetration. This takes care of, with an algorithm on the back end, that the gaps are closed as much as possible, but this just works when there are very minor gaps. So that is where this contact surface offset comes into picture. Contact surface offset is nothing but it allows us to force with a value, to define a value, that please search for a contact surface within this perimeter, within this range. This is what the contact surface offset means. This value should typically be more than the gap value. Okay, so here the gap value was 1, so I'm going to set the contact surface offset to at least 2, right? It should be at least more than 1. I can set this to 5 also. The only difference the 5 will make is it will look for a surface for a much more bigger perimeter. So let me just set this to contact surface offset 2, that should suffice, and I just go ahead and click OK. And I want to create this, right, contact pairing. This is done. I can see the surface normals, finish. One thing which I did forget was, and I can go back to the properties and change it, is the friction. Under the friction, what kind of material the contact surface needs to have, and I'm going to set this to material 3, which let's say assume is the material property of a fascia material which is connecting two organs, right? So okay, done, that is updated. So now comes the loads and boundary conditions, right? Let's plot volumes or plot elements, whichever way, right? I'm going to apply structural displacement on areas, right? So I'm going to apply a small pressure on this one, make sure, oh, so displacement has to be on the other side, this one, right? Let's set this to 0, and I'm going to push this left side object towards the right side object. So right, so I'm going to apply pressure on areas, this one, okay, very small pressure, 0.1. okay, great. So these two bodies with a gap, with a defined contact pair, will this work when I have done everything right? Let's find out. Okay, so new analysis, okay, solve. Let's try to solve this. Yeah, done, solution is done. So our contact pairing is working fine, right? If I would have not done that offset, this would have behaved differently. It could fail, the contact condition could fail, and failing basically means the solution is not found, right? There is some issue. So what you're seeing on the back end here with some lines, different colored lines, this is actually convergence criteria which is going on the back side. There's some algorithms and other things which are doing a lot of mathematics and trying to figure out a solution or simulate a solution, right? So that's what is going on in the back end. We are just going to skip over on that from that. So that's good. Our solution is all good to go. So let us plot results. Deformed, undeformed shape. So we can clearly see the results. Let's see how the results behave from an animation. Okay, of course the right side block seems to be much more stronger than the left side. So due to the pressure, it is forcing onto the right side block through the material number 3, which is filling the gap, and we do see a little bit of movement on the right side. Of course the right side, right face of the right side block is completely constrained, so that's not moving at all, but I do see some deformations which are getting translated, right? Let's stop this. Another way to look at it is if you are looking at the result viewer, let's look at the DOF solution, displacement vector sum. So there are some clear displacements which have been translated to the other body, which can be clearly seen, right? It's not like these two bodies are not interacting. So they are interacting quite well, even with the presence of the gap, which is filled with that material number 3 in this case, right? Okay, next is stress, von Mises. So the stresses are also properly getting translated. Okay, if I want to run a very simple animation of the deformed results, it should run. Yeah, this is how the stresses are getting distributed. This is good to know, you know, like, so this is how the stresses and everything are getting transmitted. Okay, so this was the second contact condition which I wanted to explain. Keep the gaps low, don't make models which are with huge gaps. Like I said, the rule of thumb is 5 to 10% gap size given the dimensions of the model, right? Like the maximum dimension of the model, the gap should be less than 10%, right? The next one would be the next simulation which we are going to pick up in the next session is going to be what if the gaps are not uniform. Like here you have a constant gap between the two surfaces. What if the second body was a sphere? Then how do you take care of the contact pairing? What is getting in contact? How the surfaces are contacting? And then from there we are going to transition to the complex simulation. So that's the plan of action. So hopefully you guys have learned quite a bit about the contact pairing simulation. This is very important, in terms of understanding of two body and multi-body problems, where in majority of the realistic cases you will have bodies with completely undulated or complex geometries which do not have certain edges and shapes which you would see in a box or sphere, as well as you will have materials, different materials which are being filled inside and which are causing the gap to be there, and you want proper interaction, bonded interaction between them so that you can find the right results. So please practice the contact pairing. This is another important set of lessons. We will continue with contact pairing in the next session, and we will hopefully then move towards the complex simulation and try to understand what happens if there is an intervention also. So we'll try to look at that as well, right? So with that, thank you all. I'll see you all soon again.